Good morning, afternoon, evening, whenever you watch this. This is for Math 58 / trigonometry. And I'm picking up where I left off, which now we're in chapter 6. And the topic that we're going to be looking at is law of sines. And with law of sines, as well as the next section, law of cosines, we're not needing to be using right triangles. These are going to be triangles that are non-right triangles, the ones I'm going to be working. It'll work for right triangles as well, but law of sines, law of cosines helps you with the other kinds of triangles. So let's get to it. Let's show you what law of sines is all about. Share my screen with you. So law of sines, and the way I'm going to draw my triangles, I'm going to try to stay with what the textbook does. There's going to be 3 angles and 3 sides, of course. Always going to identify angles as capital letters and sides as lowercase letters. And I'm going to start my angle A on the left side of what I'm going to draw, meaning over here on the left side. And I'm always going to draw a horizontal line over to angle B, so that'll be called B. And then somewhat up here would be an angle C, depending on what the measurement that we might be given. Trying to do the best job I can to draw it to scale. Then in terms of sides, we're going to identify the direct opposite side of the angle to be the side, in this case, lowercase a. And likewise with angle B, directly across would be its associated side. So we'll call it side B, and as well as angle C with side C. And that's basically what's being said down here. So here's the conclusion down here. Now, it looks like a crazy equation. You have two equal signs, but the concept is if I take away one of them, then this proportion, that equation is true. It's equal to each other. If I take away the middle, like that, then you'll see that A over sine A is equal to little c over sine of that angle. And then like manner, you'd have that proportion. Some books, maybe even ours, but some books sometimes will take the reciprocal of these and make them equal, which is going to be true. So I'll say, or you could use sine A over little a is the same as sine angle B all over little b, or any of those could be set equal to the reciprocal of this would be sine C all over little c. Okay, now flip the page, take a look and see what we got. Okay, now as an example. So this image that I grabbed is not set like I was talking to you about. So it almost looks like A is 62 degrees. Let's see. Yep. So if you tilted it this way, cover this up, then this is going to be your A. So let's call A here, and let's see if B is actually going to be, yep, B is going to be here, and then big C is going to be there. So it's just tilted on an angle. And if you went through the process and looked at the ratio, so little a is 8, so this is my little a, and directly across from angle C is little c, and this is going to be little b. So then you look at the ratio that we had, a is to sine a, so that would be 8 is to sine of 62 degrees. And then at this case, I did a little decimal approximation, so that's around 9.04. And then we calculated similarly, lowercase b is to sine of the angle 33.5 degrees. And then approximated that. Notice that these are pretty close. And the reason why they're not exact is because that's kind of the decimal approximation, same as that. If I put them in exactly, they would be the same. And in like manner, you get something very, very close. Okay, a little example, let's try this. Now I've grabbed the image here and twisted it around. Like I say, when I do these by hand, I always start at A being the left-hand side. But these are images that I borrowed off the internet and came up with some problems. And they're drawn to somewhat scale. For instance, that looks more than 90 degrees, so 105 is reasonable. And that's smaller than 90, 35 degrees. You're going to be asked to find all the remaining pieces of the puzzle or the triangle. You're given 3. Typically, you're going to be given 3. And so this side right here, of course, is directly across angle B. That's side B. You're looking for angle A, which is what I'm going to do first. I'm going to look for angle A. Big A, some students like to do this, or I've seen that. That's like an angle marker. So either way, A or angle A is equal to, and since all triangles have angles that sum to 180 degrees, then the leftover right here is found taking 180 degrees and subtracting what you were given. So I'm going to subtract those 2 angles, and whatever I get left over, which, using my calculator, make sure I don't make a careless mistake. It looks like it's 40 degrees. So angle A is 40 degrees. All right, now, side C and side A, it's not even 90 degrees, so I wouldn't even be considering a Pythagorean formula. I am going to, every time I use the law of sines, okay, here's the thing that you want to do. Every time you use the law of sines, always use the given data. Because if I use something that I've created, it may be a decimal approximation. And then when you do the calculation from there on out, you're going to get a worse approximation. So always use what you're given, meaning I'm going to use these 2 pieces together. That's B and B. So I'm going to use B is to sine angle B. And then I wanted to either find side C or side A. So let's start with C. So C is to sine big C. So now what I can do is go over here. Okay, B is given to be 7 and then sine 35 degrees. And C I don't know, but I do know the angle of 105 degrees. And now it's a matter of solving for C, which is a little bit of algebra. And if I took my pen right here, I'll multiply both sides by sine 105 degrees. Both sides. And it looks like I get little c here all by itself. So let's see if I get little c here is equal to, and that would be, let's put the 7 first, 7 sine 105 degrees all over sine of 35 degrees. And then put that in the decimal, in the calculator, decimal approximation, make sure I'm in degree mode, which I am. And I'll do that little fraction thing again. So I'm just so you can see what I'm doing. I did the little fraction thing, and I'm going to put in 7 sine 105. And then down here is sine 35. And I'm getting, okay, rounding to wherever they asked me to. I don't think that they've asked me to do it here. So let's round to the nearest angle, the nearest side, I should say. This isn't an angle, the nearest unit of measurement. So it's around 12. Some of you might say, but Jeff, you asked us to do it to the nearest hundredth. Okay. Or if I go squiggle, squiggle, this is the hundredth, H-U-N-D-R-E-D. So I'm going to round that 8 up to a 9, so 11.79. And then you'd say units of measurement if you need to. So that leaves us just to find little a. And again, you can't use the Pythagorean theorem because it's not a right triangle. So I'm going to have to do it again, meaning I want to take little a and associate it with sine of the big A. And what I don't want to do is use the C's because I've got approximations here. Don't use the C's. Use again what's given, which is the B. And plug things in. So I'm looking for little a. Now, I have found a to be exact. See right here? I have found a to be exact, 40 degrees. So I'm good with that. And then little b is 7 is to sine 35 degrees. Like manner, a is equal to 7 sine 40 degrees. Multiply both sides by sine 40. Multiply both sides by sine 40 degrees, both sides. And so we're getting divided by sine 35 degrees. Okay, calculator time. Here we go. Seven sine 40 and sine 35. And if I've typed it in correctly, then I'm getting squiggle, squiggle, 7.84. And now I found all my pieces. So that's pretty much, that's the process. Law of sines is going to get you 3 out of the 6 pieces as long as you're given, here's the key. As long as you're given a side and its corresponding angle. What I mean by this, if you're given 3 angles and you're supposed to find all 3 sides, you can't use law of sines because you have to have at least one side with its own corresponding angle. You know, let's say side A and angle A. You have to have that. And what do you do if you don't? Well, that's in the next section called law of cosines. And that's going to take care of those. Let's see what else I got for you today. I see another one down here. Okay, this gives 2 sides and in one angle. So you're supposed to find the other angle somehow. So let's try this one. Okay, this is angle C. This is little c here. This is little b. So it looks like I'm given the C's. So that's what I'll start off with. So I'm going to have little c is to sine big C. And then let's see, I guess I'm going to use the b's because I have the side b. So that's equal to b is to sine angle b. Okay, here we go. 5.5 is to sine of 63 degrees as 4.7 is to sine of, and I don't know, that's what I'm trying to find is big B. So now a little bit of algebra. I'm going to, okay, here's a thing that might have been nice. If these were flip-flopped, reciprocal, it would have been a little easier. but I can still do the algebra. Still not going to hurt me. Watch this. Both sides. So it gets rid of this one. And it moves the sign B to the top. So that means I've got sine B, and this is 5.5 over sine 63 degrees. Now all I have to do to get the sine B by itself is multiply the reciprocal of this to both sides, because these are just two numbers. So ultimately I'm going to end up having, let's see if I can do this up here. I'll do it up here. I'm going to go sine B is equal to, I got a 4.7 already. And multiplying the reciprocal over here to this side, I end up having sine 63 degrees all over 5.5. And hopefully you remember how to solve for B, how to get rid of the sin phrase off of the B. We take the inverse to both sides. Basically, we're going to end up on the left-hand side as B equals, and then it's sine inverse. And then I've got the rest of this as its argument. And now I'm going to put the whole thing in. I'm not going to approximate it until the very end. So I'm going to end up having sine inverse. And now the fraction. And I've got 4.7 sine. It's like 63 degrees. And scoot on down here at 5.5. Close up my parentheses, hit enter, keep my fingers crossed. I get a 49.59. 49.59. Okay, so, and that's angle B. So that would be a degree right there. And if I compared, look at the sides right here. Okay, 5.5 is bigger than 4.7. Therefore, this angle should be bigger than the one I just found. And it is. Now, the last thing that you would do, and I'll pose this to you because I think I found the hardest part right now. The last thing, well, there's two more things. You need to find the other angle, which is the easy part. All you have to do is subtract these two angles from 180, and then you get angle A. That's the easy part. The last part that you want to do is find the little a, and then you use law of sines all over again. But I didn't even ask you to find little a, did I? I just wanted to find, there's the B, and then the A I just told you how to find. You can do it. I know you can. Okay, I'm going to do, I think, one of these for the time we have. And let's take a look at, I guess we'll just do the first one. So let's agree from here on out, this is what I'm going to be drawing. Instead of grabbing images off the internet, I'm just going to draw it. That the angle triangle, the angle A is going to be to the left. And angle B, I said directly east, so over to the right-hand side. And angle C would be somewhere up here. So let's start with that. So here's, I'll call it A is right here. There's a dot for A. And then directly across right here is going to be B. And now, the thing, before I figure out the C and try to draw this as close to scale as I can, notice that 46 degrees, okay, here's 90. Okay, this would be 90 here. Okay, that's 90. Okay, So 46, gosh, that's about 45, 46 right there. So if I made my the side that's adjacent, which is really side B, and then notice angle B is 71 degrees. So here's 90 degrees. Okay, I don't want to have B way over here. I don't want to draw it like that because this angle right here looks way too small. I want to try to draw it to scale. So I'm going higher, 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 higher. Maybe there-ish. Okay, maybe here-ish. That's about 71 degrees. So I'm just going to put this in as your 46 degrees, and this is 71 degrees. And then maybe have my line solid now. Now I've got a triangle based on what I was given. And little c, this is little c, is 56. Those two tick marks right there, that's not a degree for those of you that are wondering. I've never seen the tick marks. We're going to call those inches. Inches. So in these, that's not like in degrees, there's minutes and seconds. Yeah, no, it's not. This is inches. So if you didn't like that, write INCHES, inches. All right, so this is equal to 56 inches. And your job is to, I guess, let's say just find the rest of it. Now, this angle C is the easiest of the three. So angle C is found to be 180 degrees. And then you're going to subtract what you're given. So angle C, whatever the leftover is, subtract 46 and subtract 71. The leftover is 63. So this right here would be 63 degrees. So they all add up to be 180, and took care of that. Now I have to decide what's left, which let's say it's lowercase a. And if I want to find lowercase a, you would say A is to sine big A as, and I have to use a ratio of either the B's or C's. Now it looks I was given lowercase c. I'm going to use that one. So I'm going to use C, and that would be sine of big C. So here we go. Little a I'm trying to find, and that would be sine of big A is 46 degrees as little c, 56 inches, is to sine 63 degrees, which I found, and that's exact. And now, just like the previous problem, I just solve for a, which then gets me little a is equal to 56 sine 46 degrees, and that's all over sine 63 degrees, a squiggle squiggle. A little fraction thing again. I'm right here. And then back to a sine 63 degrees. Okay, about 45.21 if it's two decimal places. Inches, units of measurement, inches. So that finds A. And really all there is left is B. And you do the same thing, except with just with the B's. Continue to use the C ratio, though, because that's given to be the 56 degrees. You don't want to use the A's because that's a decimal approximation. And so you can do that. I know you can. Just take the ratio, B to B, B to sine B, and then C to sine C. and replace all the values that you have and solve for the last variable. The question I might have for this one, remember I said you've got to have, in order to do law of sines, you have to have an angle and its associated side to be able to do it at all, period. So if I look at this, I can do it. See, 43 degrees in A. So I can find the other pieces, namely angle B, based on that statement. But if I had angle A and side C and side B, I couldn't do it. I couldn't answer it with this section. But this one I can do. This is very similar to the previous one I just did, so I'm going to let you take care of that one yourself. Now, number 4, I have down here. Think about it, because sometimes you just blindly go into a problem without even thinking about, here's a question, can that even be a triangle? Sometimes you just jump right in and say, I think I'll just go ahead and beat this thing up with a formula. But if you add those two angles together, knowing that there's a third angle out there, you add those two angles together, it's more than 180. Yeah, it doesn't even form a triangle. So you can't even do it. Can't do this one. Impossible. Can't even do that one. So there might be a problem or two assigned in the textbook. Keep a lookout for something like that one. Okay, so I'm going to end it here because this is part 1 of law of sines. The part 2 is a law of sines, but it gets a little, I'll call it complicated, and there's a lot to it. So next video, part 2, I'll start off right here where I left off, and then we'll do a couple word problems along with it. And until the next time, be safe.